Welcome to the Computing There I Was podcast. I am your host, Richie Bilak, and today I will be talking with Marc Cohen. Hi, welcome to the Computing There I Was podcast. Today we're talking to Marc Cohen, who's recently retired from Google, and he'll tell us more about his story. How are you, Marc?
I'm good, thanks. Nice to be here, Richie.
So you are the first interview I'm doing across continents, I guess, because I'm in New Jersey and you are in London.
Right.
I always begin this podcast with just basically asking, how did you get into computing to begin with?
Sure, yeah. So I guess you could say I inherited it because my father was a programmer.
Oh, really?
Back in the 60s. I don't know if I could say the 50s or not, but definitely the 60s because that's when I was a boy. And I remember him working on his software. I had no idea what software was when I was really little, but I remember he had these little plastic templates that he used.
Oh, yeah.
These, which he used to make what we called in the day flowcharts. I don't think anybody makes flowcharts anymore, but as a little kid, I was like, oh, that's cool. He's doing artwork and that's his job, but I didn't really understand what he was doing. But, he was a COBOL programmer on IBM mainframes, which was kind of the standard programming venue in those days. And he always encouraged us, my siblings and I, to take computer programming as soon as we could. I was very fortunate in that I went to high school in Livingston, New Jersey, which happened to have a programming curriculum, or it was a couple of courses like basic. And
when was this? This is like early 70s?
This was mid 70s. So I graduated high school in 78.
Okay.
So mid 70s, Livingston High School had a programming course, which pretty good for that era for 16, 17-year-old kids. And my brother took it before me. He was 2 years older. And I remember one day just wandering into his bedroom, as I often did, and there was this book on his night table called Basic. And I couldn't figure out what the heck that meant. And so I opened it and started reading. And as a kid, I'd always loved puzzles and math. And I started reading this book. It was about the basic programming language.
Right.
And I was like, wow, this is cool. This is using BASIC, this computer programming language, to solve puzzles. So I just kept reading it. And when I finished, I was like, that's unusual. I mean, I realized I was sufficiently self-aware to realize at the time that for me to pick up what was essentially a textbook for a kid that was a couple of years ahead of me in school and devour it, it sort of spoke to me. It said, there's something here for you, I think.
Yeah. So
I took programming courses in when I got to the same age.
Did they use BASIC?
They used BASIC and Fortran. It was interesting. The Fortran, we did the BASIC. We had one of those old teletype terminals where you were connected live to a BASIC interpreter. But for the Fortran part, we used punch cards.
Right.
And we didn't have a computer. The teacher had some kind of arrangement where he would take our punch card decks and get in his car and drive to this company that was down the road from my high school. So he somehow finagled a deal with them where they would let them load our programs. But I remember that for two reasons. One is it really showed this guy was dedicated, because every day after class, he was just making this road trip and not wasting his time, but spending his time helping us. So he was quite dedicated. And the other thing I remember from that is, if you made a mistake, even just a syntax error, it took you 24 hours to find out.
Yeah.
So it really drilled into me. You need to be very careful and read and reread your code, which was a good.
Well, Right. When I kind of got started similar way, except in college. I was in a physics class, and we had to do like the results from the lab processed by little Fortran programs. And the very first time I did it, I made a mistake on my job card, JCL card.
Yeah.
So I submitted the deck, and nothing happened. Nothing came out.
Yeah.
It's kind of just
Yeah, if you messed up the JCL, it was like it couldn't even get off square
right.
one.
So somebody finally looked at it and says, "Oh yeah, this is wrong," and I fixed it.
Yeah, all those / cards.
Yeah.
All that stuff that I've mostly purged from my memory, but at
Right.
one time that was the magic incantations we used to talk to a computer.
So, what kind of programs did you write in high school?
It was mostly just following the curriculum and trying a few little experiments. I remember I have one actually vivid memory from that period of having an assignment to print a table of factorials.
Oh,
So for anybody who doesn't know what a factorial is, it's the product of a sequence of numbers starting at 1 and going up to the number that you want the factorial of. So factorial of 4 is 1 times 2 times 3 times 4.
right.
And so I wrote this Fortran program, and I used a nested loop. So I wanted a table from 1 to n. I had, the equivalent of 4i equals 1 to n. And then I had an inner loop, 4j equals 1 to i. You know where this is going, right? I would calculate, 1 times 2 all the way up to I, and then I would start over at 1 again. And I didn't realize how foolish this algorithm was, but I was proud of myself because it worked, and I showed it to my dad, and my dad said, you're doing all this calculating and then you're just throwing it out the window the next time through the loop. Why don't you just think of a better way to do it? And I realized I didn't need a nested loop. And
Right.
I think that, not that that was any kind of a deep revelation, but I think that was sort of when my eyes opened a little bit to the idea that it's not just whether the program's right or wrong. It's a question of like, it can be written many different sorts of ways, and it can be more efficient or less efficient, or more readable or less, more comprehensible or less comprehensible. Right. So it started kind of opened my eyes to the notion that programming is not just black and white; it's an art.
So you said you went to school at Rutgers?
Yes, yeah. I was a math major. I really loved math. I loved programming too, but I don't know, somehow math felt like my first love. And I didn't really know what I wanted to do in real life.
I was in the same boat. I was good at math, and I was just taking math because I liked it. And
it's like what 18-year-old knows where they're going to go.
Right, exactly.
One thing I've noticed that's different between the U.S. college system and the U.K. system, because my daughter went to uni here, is that when you enter a university here, you have to declare your major effectively. Whereas, in the U.S., it's conventional to just kind of take whatever courses, a mix of like required and elective courses in the first year, and then you sort of figure out what direction you want to go in. Anyway, I picked math because I loved it, but I also took a bunch of computer science courses. I was always drawn to this overlap, like this idea that the computer is almost like a magical math tool. Like you can use it to solve math problems. I remember taking a numerical analysis course where we learned Newton's method.
Yeah.
This thing where you sort of slide down the tangent line to find it's actually...
I have a funny story about that. When I was in college, I was taking physics, and I got a calculator, but at the time, calculators did not have a square root. So I used to do Newton's method to the square root, by hand.
You manually with paper?
Yeah. With calculator.
With calculator.
Like 2 iterations usually get close enough. So
yeah. And it's funny because, Newton's method is basically a simplification of what we would now call, what's the term for, finding the minimum of a multidimensional surface,
Oh, gradient descent.
Gradient
Okay,
descent. Yeah, it's
right,
basically Newton's method is basically
right, right.
two-dimensional gradient descent.
Yeah,
So
yeah,
that turned out to be a pretty important tool
right.
in 2025. But anyway, I remember we were supposed to just do this stuff by hand, and I wrote a computer program to implement the algorithm. And I wasn't asked to; it wasn't part of the assignment. But I just saw these things just fit together so well, and I showed my. And it was kind of like, again, the same experience as with my dad. I showed my teacher. I was so proud of myself. And he was like, that's great. But you know what? It's not converging fast enough.
Right.
He could tell I had a bug just by looking at the successive precision in my answer, which was another interesting experience. And I went back and, fixed the program till I was happy with it.
Now, what programming language? What was the computer environment at the time?
Let's see. Trying to remember. I think it was Fortran back then. But Rutgers had an array of different computer types. They were starting to get into the new mini computer era. So they had some digital equipment computers. They had a system I remember called TOPS 20, which had a nice interactive, what we would in that day call time sharing system attached to it. So it was a combination of probably BASIC and Fortran mostly in those days. But towards the end of my time at Rutgers, the C programming language was starting to work its way into the university, but not through the faculty. It's the faculties usually like they've got their way of doing things. They came up with a certain pattern, and other students that I interacted with were turning me on a little bit to this new programming language from Bell Labs.
So this is like late 70s?
Yes. Yeah. I graduated from Rutgers in 78. And the other thing a good experience I had at Rutgers was I got a job at what they called the aid station. So it's kind of like the help desk.
Right.
For computing. And this was a super great experience because it was just like being challenged every day with different sorts of problems, and great for developing your skills and your knowledge. And if you like this puzzle solving kind of mentality and to get paid for it was great. So that was a good experience as well.
Both my kids went to Rutgers. So,
cool.
My son was a computer science degree. So.
Okay. Yeah. By the end of my time at Rutgers, I was unsure whether I wanted to go into computing or math. And by math, my dad was advocating I go into actuarial sciences, which was very lucrative, and it was hard to get into through these very difficult exams. But I took a couple of the exams and I did pretty well on them. And so my dad was kind of nudging me in that direction, but my heart was more in a computing job. So I remember I had two cover letters and two resumes. I had the math version and the computing version. And I did some job interviews, and I ended up getting an offer I couldn't refuse. It was just so good, it like knocked everything else off the table. And that was the Bell Labs job.
Yeah.
And the reason it was so good was not just because, Bell Labs was prestigious and everything, but the reason it was so good is back in those days, Bell Labs had a program called OYOC, 1 year on campus. And the idea was they would hire grads, bachelor's degree grads in sciences and computer science and math and electrical engineering. And they would send you away for 1 year to get a master's degree. They would pay the tuition.
That's fantastic.
And they paid you a salary. It wasn't the full salary that they hired you with. It was like 2/3 of the salary, but still.
Yeah.
It was an incredible opportunity. So I ended up going to Cornell. I got a Master of Engineering degree in computer science, which was a 1 year program.
That's funny. My two previous interviews were also Cornell graduates.
You've got a pattern going.
Yeah. No, I went to graduate school to NYU, and the bank I worked for had tuition refund, right? So they helped.
Hmm.
So I was getting master's degree in math, taking my math courses, pretending they were relevant to my job.
You're just studying whatever you wanted, whatever you were
Yeah,
interested in.
basically, I was like into number theory and
Uh,
some abstract stuff. Yeah.
that's cool. Yeah, Cornell was really an eye-opening experience for me. I took a system programming course there, which was
Hmm.
basically all about Unix. Like the curriculum was there's a famous Bell System Technical Journal, which was the kind of technical journal that was
Right.
formally published by Bell Labs. And there was a famous edition which was just like introduced Unix to the world.
Hmm.
And we just went through all the papers in that journal as part of this course and did some other things. But that was just eye opening for me. And of course, they had good computing facilities, Unix based computing
Right.
facilities. And I remember having this, I don't know what the word is, the light bulb went off for me
Hmm.
where I was just like, this is how computers are supposed to work. Like, this is how operating systems should be
Right.
built.
Right.
Sometimes you don't know until you see it, but once you see it, it's immediately clear that this makes a lot of
Right.
sense.
So
So
once you got your master's, you went back
yeah,
to Homedale.
after Cornell, I went back to Homedale and started working there. I worked in the Homedale Computer Center. So I was essentially an IT person,
Uh-huh. Okay.
but IT at Bell Labs was kind of a different sort of IT than you can,
It's like an SRE today, right? At Google.
and a research and like a computing, like you could do crazy things. I'll give you an
Mm.
example, like the
Yeah.
computer center at Bell Labs. Again, this was in the era when IBM was still like the dominant
Yeah.
computing
Yeah.
vendor, and you would have IBM mainframes that cost maybe $5 or $10 million, or maybe I'm
Right.
over a little, maybe 2 million, but whatever it was, there was huge investments in that era, and Bell Labs used them with the normal IBM operating system and software for a
Right.
lot of their engineers and researchers who were doing Fortran programming. But there was a faction that had started adopting Unix on lots of these mini computers,
Mini
so
computers, right?
EDP-11s and then VAX 750s and 780s and all these other
Yeah.
models. But those mini computers were mini. They just didn't have the horsepower. So what we did was we built out lots and lots of mini computers and networked them together. And so we were essentially building a pretty significant distributed computing network in the days before distributed computing was as well understood
What
as it is
protocol?
now.
Was TCP/IP available then, or was it something
Well, this is
else?
actually before TCP. Well, TCP/IP existed, but it was sort of
Hmm.
like hidden up in the internet, and the internet
Mm.
wasn't a thing that many people
Right.
were connected to back then. So back in those days, there was something called UUCP,
Yes.
Unix to
Uh-huh.
Unix
Yeah.
copy.
Yeah.
And then there was something called the R commands we would use, although the R commands were later, and that was built on TCP/IP. But yeah, what was interesting was that even with working out all these, the short answer to your question is we had a lot of custom hardware, something called data kit
Right.
that we would use to network these things together before the TCP/IP
Hmm.
Ethernet era really took off. But after a while, having all these mini computers and trying to figure out how to get them to work together, we were looking at these IBM mainframes and saying, why can't we run Unix on one of those? And I wasn't involved in this myself, but there was a project to port Unix to an IBM mainframe. And it's hard to overstate how crazy that was. Like in those days, you didn't buy a $2 million computer and throw away IBM's operating system and
Right.
just
Right.
put Unix on there. But they did that. They called it Maxi Unix. It was a huge success back in those days. They could, have support 10 times as many users as a
Wow.
VAX 11780. So that was the kind of bold thing they did in those days.
So this was in the Homedale. That's the building office that everybody sees. That. Have you watched Severance, the show?
I've read about it, and I've seen photos of that they filmed part of it in the lobby of that
Yeah,
building,
yeah,
but I haven't
yeah,
watched it myself.
yeah.
No.
No, that's if you're into weird science fiction, it's kind of fun.
Yeah, I
But
should
yeah, it's
check it
it's
out.
nice to see the building because I go there occasionally because it's like I don't know 15-minute drive from my house.
Yeah, yeah. No, I've been back there. I went there with my daughter. Partly, I wanted to show her the Horn telescope on Crawford Hill,
Yes, yes,
where
yes.
they.
Actually, there was it last year. I think they're going to open it as a park in the museum, and they had like an opening ceremony. And the guy who worked on it when they discovered the background, cosmic radiation, was
Hmm,
there to give like a little speech. It was great.
that's awesome. Yeah, so that's an amazing site in the sense that they confirmed the background radiation from the
Right.
Big Bang there and
Yeah.
won a Nobel Prize for that. But the other reason I just wanted to see what was happening there, and it's really weird. It's now like a
Mall.
combination sort of shopping plaza community center now. Yeah, but I mean, at the time it was amazing. It was a huge building, huge campus, and there was this very kind of university feel to it.
Hmm.
There were a million clubs, and you know, after work you would go outside, and I remember playing ultimate frisbee with people, and it was just this very, I don't know, researchy, laid back kind of environment. It was a kind of place where you could go to work in shorts and t-shirt and nobody batted an eye.
Right.
Um, it was a nice culture, and in many ways, I kind of think it predated the Google
Right.
culture in terms of attracting like really thoughtful and deep, really accomplished people and giving them the freedom to kind of pursue whatever projects they felt made sense, and also having like this nice environment in which to.
Well, if you think about all the stuff that was invented at Bell Labs, like in the 40s and the 50s and the 60s, it's just amazing. You
Yeah,
know,
yeah,
people
like
talk about Silicon Valley, but it really all started on the East Coast.
right, like the mobile phone, the genesis of the mobile phone, and
The
the
transistor,
transistor, and
Unix.
yeah, I mean, there's so many things.
So, looking at the notes that you sent me, I see Lucent. So, at some point, Bell Labs was kind of taken over
Yeah, it
or split.
was when I went back to Homedale in '84 or '83. The very next year, they broke up the Bell system. There were a few like big reconfigurations of the company that I worked for. So like I was totally there for 29 years, I think, and
Wow.
the name of the company kept changing, but I never like moved my desk or or the person I was in the office with was always the same person. But yeah, in '84, the Justice Department reached a settlement with AT&T to split what they called them in that day was the Bell system. So they
Right.
divided the Bell system into three parts: the local operating companies, the manufacturing part, which was called Western Electric, and then they kept Bell Labs and was it the long? Well, I guess I might be confusing it, but Bell Labs stayed with the long distance network part of it, I believe,
Hmm.
and that was in '84. And then, like a decade later, they split out all of the manufacturing into Lucent Technologies. And
Okay.
at that time, I had moved from the computer center to the product area. I was working on different communication systems, and so I was part of that, portion that built things and sold products.
Hmm.
And so I went with Lucent at that point.
So, you're still writing software, though, right?
I was always writing software. I mean, even when I was in the computer center, like
Hmm.
I wrote a whole email system from scratch for the IBM mainframe. I should back up a second. When I
Uh-huh.
got back from Cornell, I was really excited about Unix. And I
Right.
happened to be in the group organizationally that was responsible for the IBM, legacy
Right.
stuff. So I was actually kind of frustrated because I was just so excited to work on this new cool stuff. And here I had to work on the stuff that my dad worked on basically. So I was always looking for ways to do something fun. And they were saying, and the system that we used at the time was called TSO, time sharing option.
Yeah, yeah.
And it kind of like tells you something about what computing was like in this period, that time sharing was considered an option, just an add-on capability. Whereas with Unix, time sharing was the whole point of the system.
Right.
And I should say for anyone listening, they might not know what I'm talking about when I say time sharing. In the old days, we submitted our programs either through a terminal or through a card deck, and it was completely asynchronous. We walked away, we came back later. If we were lucky, in an hour, we get a printout. If not so lucky, a day later. But it was what we would call a batch job.
Right.
And the idea of time sharing was that you share the main processor with other people, and it's a very interactive experience. You're sitting there typing things, and the computer's immediately responding to you. That was the sort of standard model of computing with Unix. And in the IBM world, this time-sharing option was trying to catch up to all this new stuff.
Right.
So they said, we need a mail system, an email system for all our TSO users. And so I just built a mail system from scratch, this was before the era of open source, of course. So that was fun. I basically implemented the SMTP protocol and a user agent, and had to deal with things like, infinite forwarding loops and Postel's law about, interpreting all the RFC 822 headers and all that kind of stuff. So
That's fancy.
That was the kind of thing you could do as a young engineer at Bell Labs. Like, we need a mail system. Okay, I'm going to build an email system. And off I ran. I did a lot of coding in the computer center. And I also did a lot of work on networking, because I was kind of watching this progression of networking technology happen. And I was very interested in it because I could see something coming, a big wave coming. So like when I started, everything was just these terminals, asynchronous terminals, we called them. And what that meant was, the computer is somewhere far away from you, and you're just typing, and it sends what you type, and you get back the answer. And there was a succession of networking technology that was created to improve that process, both in terms of making it go faster with faster and faster modems, but also trying to enable more intelligence locally, to go from what we called a dumb terminal to something more sophisticated. At the same time, in the internet, there was this TCP/IP protocol suite that was kind of making networking, revolutionizing networking. It had been like a thing that was sort of cordoned off into the internet. So only researchers and academics had access to it, and government people had access to it. But after a while, you could see what was happening. It was getting more and more efficient and better functionality. And I think a big step forward was the Berkeley Unix system.
Right. I was going to say, when Berkeley Unix system came out with the TCP/IP included.
Yeah, they added.
I had to deal with networking, like from DECnet to SNA to X25, that kind of stuff. All these custom networking protocols.
Right.
And when TCP came along, it just kind of swept all that away.
Yeah, I mean, at the time there was a big push in AT&T to develop this thing called ISDN, Integrated Services Digital Network. Not that different, a generation after X25, but the idea was like, these were people who, like, their culture was circuit switching, if you know what I mean by that term, which is like the way you connect things in this world is you dedicate a path, a channel, a certain amount of bandwidth, and those things are end-to-end connected. And that was sort of the whole legacy of the Bell system. And I think people, I don't want to generalize too much, but a lot of the culture was sort of oriented around how can we do all this cool new data stuff with circuit switching? And that was a little bit about what inspired ISDN. But TCP/IP was a totally different model. It was packet switching, where you put the data into these chunks, and you split the data, the chunks up into separate packets, and you send them, and they can go travel different paths, and they get reassembled at the end, and all that stuff. It was a radically different approach. And I remember One thing that really stands out for me when I think back is we had a guest speaker one day. It was announced very last minute. It was Steve Jobs. Now, Steve Jobs, I mean, when I say a guest speaker, it wasn't like just my department. It was like in the
Right, right.
auditorium. And Steve Jobs was very well known. It's not like he was, some unknown person. But at the time, I think he had left Apple under maybe
I think,
unpleasant.
yeah, he was forced out of
Yeah,
Apple at
I
one
think
point.
that, yeah, I thought that was the case. And at the time, he was the head of Next Computer.
Right.
These like cube, like
Yeah.
boxes. And he gave this really interesting talk where he was saying, look, AT&T, you're missing the boat. Here's what I need. I need to be able to connect my boxes to any other box, forget me. The whole world needs you to build this network. And what he was describing was the internet. It was already there, but it hadn't become a commercial thing. It was something that the Defense Department and researchers and universities were connected to, but it hadn't become and I think that's really what he was advocating for, was the internet.
Mm-hmm.
And AT&T, I just don't think got it. Some people got it, and there were certain proposals to do packet switching, but it's always like packet switching on top of this ISDN layer.
Right.
So anyway, watching all that from inside the computer center, I started advocating quite a bit for these kind of networks. And I remember I wrote a document called a Framework for Distributed Computing in Bell Labs. And it caused a little bit of a stir, and it inspired a lot of people to start using this technology inside Bell Labs. I don't want to sound like, take credit for more than I deserve. It was just I was just an advocate for a new way of doing networking. Right. And it eventually, it was a lot bigger than me. Eventually, people figured out how to do, like my document was proposing an Ethernet backbone in the computer center, which we actually built. But not long thereafter, people figured out how to do Ethernet over twisted pair and we use all the existing cabling in a building and, 10 base T and all that stuff. So it was, at that point, the handwriting was on the wall. This is the way that distributed computing and networking will be done. You're asking about programming. Yeah. So after my stint at the computer center, I think it was roughly a decade there, I wanted to try doing something different, and I got into product development. So at that point, I started still in New Jersey. There was a Middletown office.
Right.
I don't know if it's what's going on there nowadays, but
not sure it's anything there.
But I moved over there, and I worked on something called Definity, which was a PBX. A PBX is a private branch exchange. It's a telephone switching system for businesses.
Right.
And I worked on some wireless phone systems, again, for businesses, we called it Wizard 2. So yeah, a bunch of different types of communication systems, but still back in the old school at that point. At some point, sorry, were you going to say something?
No, I was going to ask, so around like in the late 80s, early 90s, this whole object-oriented programming stuff started to come out.
Mm-hmm.
I'm curious if you were touched by any of that. Like, did you get to C++ or?
Yeah, I mean, I started using C++. I was excited about it because, one, it was a Bell Labs invention, and it seemed like everybody was considering it to be the next big thing, like the way to write programs. And so I did dabble a lot with it. I probably wrote some programs, some smallish programs with it, but I didn't do any super heavy duty work on it in the comp center era. And then when I moved on to like these communication systems, they were almost all C because of, real time performance considerations. But so in the mid 90s, my wife wanted to go to vet school. So she had been a software person herself. She worked at Bell Labs for a little while. We met at Cornell. She worked at Bell Labs in Homedale with me for a few years. And then she worked at a startup company in Eatontown, which you'll know.
Okay. Yes.
And she decided she wanted to go back to her first love, which was animals, and to become a vet. And there were no vet schools around us. In those
Right.
days, there were only like 20 some odd vet schools in the whole country. So we started looking for where is there a vet school and also a Bell Labs that I could maybe transfer to. And we ended up in Columbus, Ohio, where
That's interesting.
which
I've been to Columbus. That's a nice city.
it was nice there. We had a good time there. Our daughter was born there.
Uh-huh.
And I continued kind of working on communication gear in that location. So I worked on the Conversant voice response system. So this is one of these systems where you call a phone and it says press 1 to do this, press 2 to do
Uh-huh.
that, and all kinds of special custom hardware and software. I also worked on Intuiti Audix, which was a famous voicemail system. It was probably the most widely used voicemail system in
Okay.
private use. Built an SS7 signaling system 7 protocol stack, top to bottom for a voicemail system. And at this point, I think that might have been the first time I became a manager in Columbus, and that was
Mm-hmm.
good. That was an interesting experience. And I think one of the things I've always done throughout all this time is I've always been a kind of a tools person, meaning I would always look for tools to build and things that would make my life easier, but I would get a charge out of it if someone else could benefit from it
Right.
too. So
Uh-huh.
in all these jobs, I would always do that sort of thing. But yeah, I mean, Columbus was a fun experience. I enjoyed all the different products I worked on and all the different people I got involved with.
Do you have any kind of interesting debugging stories?
I'm going to have to think about that for a second. I remember one that I never debugged, so it's not a very satisfying one, but it just about killed me. One of those
Yeah.
things that, yeah, I just night after night working on this. Nothing jumps to mind immediately, but I always have felt like one of the attributes that I'm most grateful for is my persistence. I would not think twice about staying up all night to work on software. And I think that served me well. Yeah, I'm not remembering any particular
That's all right.
debugging
I mean,
adventure.
one of the things that I find is that when you get stuck in some tough problem, sometimes actually stepping away from it, taking a nap or, going for a walk or do something else prods you to find a solution. It's like,
Yeah.
there was a startup I worked at. I remember once there was I was really always into these concurrency problems, which are always kind of tough, where a bunch of my friends decided to work really late to try to fix this weird problem we were having. And I said, nah, I'm going home. And then next morning arrived, I knew exactly what the problem was, just, debugging by thinking. And I came in, I showed it to them, and they grumbled because they stayed late and they couldn't figure it out.
Yeah, that's a good point. I've had that experience as well, and I think that I haven't always been good about doing that, like taking the break when you should, but I've often found that the answer to a hard problem comes from my unconscious mind when I'm
Right,
not
right.
trying to figure something out. For some reason, the shower has always been
Right.
it's a
It's very
cliche.
it's a very typical thing. You can even like famous mathematicians talk about that happening to them.
Yeah, yeah. When I was in Columbus, I remember one of the things that was fun was I had a very primitive smartphone. It was a Nokia phone, and it was one of these. I mean, this was the late 90s, so it was one of these very clunky
Right.
old phones, but it had the ability to like download files.
Mm-hmm.
And I got this, so I worked on a voicemail system. So I got this idea that what if I just downloaded the the voicemail right to the phone and played it on the phone. This sounds ridiculously simplistic, but it was a big deal at the time because you had to normally make a phone call and type 1 to listen to your message and all that stuff. And this was the first time I think a telephone system pushed a message to the phone the same way it works now. And so I prototyped it and I submitted a patent application with my collaborator, and it got refused because it wasn't novel enough or something like that. But then a few years later, when Apple came out with the very first iPhone, they teamed up with Lucent to integrate it with their voicemail system. And it was exactly the kind of design that I had envisioned, but I was just maybe a little too early for that.
So how did you wind up at Google then?
After Columbus, my wife and I were a little bored with Columbus after about a decade. It's been a theme for me. Like every 10 years or so, I get bored and want to move somewhere new. So we were looking at the West Coast, and I flew to Seattle and interviewed with Microsoft, and I got a job offer. So I was all set to join Microsoft. This is 2005, I think. And told my manager, and my manager said, wait, don't take it yet. And he talked to his manager and got back to me and said, we have a request from AT&T. This is now I'm at Lucent, so I'm not at AT&T anymore. I said, we have a request from AT&T, which had a big office in Seattle, to have a consultant to help them with our, administer and manage and understand, basically just get the most out of our communication gear. And I happen to know a lot about the specific products that AT&T was interested in. So they said, we'll relocate you and we'll, let you work from Seattle. So I was like, okay. I took that offer. We moved to Seattle, and I did stuff for Lucent, which turned into Alcatel-Lucent, which since then is merged with a French telecom company, Alcatel. And since I left, it turned into Nokia, I think, or got absorbed by Nokia. But anyway, I worked for Alcatel-Lucent for a few years in Seattle, and I got bored again. So I thought, I've been doing this telecom stuff for so long. I would really like to sort of jump into the new world, And in 2011, I interviewed at Google in the Seattle office, and I was fortunate enough to get a job offer. And I joined the developer relations team. For anyone who doesn't know what that means, developer relations is basically helping developers. This was Google Cloud. So it was helping developers and companies get the most out of Google Cloud. So the job was basically write articles, give talks, write sample code, in some cases write libraries and tools and demos. And I guess I knew this job existed, but I just didn't realize the value equation for me personally. It was like write, which I love to do, code, and teach. It's like, it's the dream job for me. So I was happy to start doing that. And I did that in Seattle for about 3 years, became a manager there, and then moved to London. And I was continuing to do cloud developer relations in London for up through last year.
How do you find, so being manager, you were manager at Lucent, right? And then at Google.
Yes, I was.
How did you find, how did they compare?
So there were some things I enjoyed and some things I didn't. The things I enjoyed the most were helping people kind of elevate their career, helping people figure out ways to solve problems. I mean, part of the job of the manager, I think, is to, share whatever wisdom you might have. Things like you just said about, maybe it's time to take a break instead of continuing to knock your head against the wall, those sort of things. But also, I really feel like getting out of people's way is important for managers, and making sure no one else is getting in their way. Right. Being like eliminator of roadblocks to me is a key thing. And I think some people have this notion that the manager is supposed to be the smartest person in the room, or the tech leader. And I get that you will typically have a lot of experience and knowledge, but I always felt like the people that worked for me did their best when I just helped them solve the problems that they wanted to solve. The things I didn't like were, after a while, like if your group gets big enough, most of your week is spent synchronizing with people and checking
Right.
with other people. And it's a lot of context switching, like, oh, I have to sit down with so-and-so and I have to remember what they're working on and what challenges they were talking about last week. And it was just, felt like my days were becoming very compartmentalized, and
Right.
I was never getting me time. And so after, I don't know what it was, 4 years maybe, I feel like it's time for me to get back into being an individual contributor. And I think another maybe interesting thing, I don't know how unique it is, but another interesting thing about both Google and Lucent Bell Labs is it didn't have this hierarchical feeling that, like, once you become a manager, you've moved up the ladder. And so going back down, returning to becoming an IC is tantamount to going back down the ladder. It's like, it was seen in some circles as a negative thing. I never felt that at Google or Lucent.
Yeah, I think I went through a similar path at Google. So I became a TL, which for me is like the ideal position, because you kind of drive the technical direction. You get to do stuff technically, but not all the way down to the details. You can say, well, here's a member of your team says you deal with that and sort it out.
Right.
And then I became TLM, which at Google is like the worst of both worlds, because you have some managerial responsibilities while you have the TL responsibilities. I did that for a while. And then I did like you. I said, I have enough of this stuff. I don't want to go to meetings anymore. I don't want to do performance reviews. I just want to do technical work. So I stepped back to be an IC, and I'll be retiring from Google next week. So
yeah, I think that's great that you had the flexibility, and that I had the flexibility to be a manager when it was felt productive and satisfying, and then switch gears when we wanted to pursue something else.
So the one question I always like to ask, what advice would you give to people who are thinking of entering this field today? So
I talk with a lot of young people because I didn't mention this, but a theme throughout my career has been teaching. I've always done volunteer teaching. Sometimes I taught Python programming at University of Washington for a while. So I've always done teaching, either paid or volunteer. And it's always put me in contact with young people. So I've had some time to think about this question. One of the things I like to tell them about is imposter syndrome.
Mm-hmm. Okay.
Which, are you familiar with that?
Yes, of course.
Okay, yeah, I think it's not so unique nowadays. I think it's entered the mainstream culture, but I'm not sure how many young people know about it. But for any younger listeners listening to this, it's the idea that you don't really deserve the success you've achieved in life, because you're maybe not as competent as everyone thinks you are, and you've managed to kind of pull the wool over everyone's eyes, but at any moment you might be found out. So you better be careful. And I've definitely had this experience, this feeling, through different parts of my life, and I think it's pretty common, probably more common than most people realize. I've read that it's been found to affect more competent people than less. Yes.
I've have a quote from John von Neumann, of all people, who said about mathematics. He says, in mathematics, you don't know what you're doing. You just get used to it.
Yeah, I never felt like I knew what I was doing. I always felt like I was making things up as I went along. And that sort of contributes to the imposter syndrome, because you look at all these other people and you think, wow, they have a plan. They know exactly what they're doing every day. But in reality, they don't. You get that impression. But anyway, I guess the message I would give to young people is, if you experience this, it's common. It's something that affects a lot of people. And just try to tell yourself that I'm here because I worked hard to get here, and I'm probably pretty good at what I do. The other thing I like to tell young people is how important I feel like communication skills are. To be more specific, I sometimes get this question when I was working at Google. People would be like, "What language should I learn to so that I can get a job at Google?" And I would always tell them English because programming languages come and go. You can learn them pretty quickly, but being able to really effectively express yourself and marshal other people to join forces with you on a project has been so critical to everything that I've experienced in my career that I think we don't maybe invest enough in those writing skills and speaking skills. And I always encourage students to give a talk at a meetup or some user group or something like that. And they're always like, I don't know anything yet. And I'm like, that's okay. You will learn. If you sign up for a talk in 3 months, I guarantee you will learn because it's a forcing function. And I also like to tell them, you don't have to know everything. You just have to know a little more than everyone else.
That's funny. That's like one of the things I always tell students as well. I also talk to lots of college students, and I've taught programming at NYU and Columbia kind of as a side thing. So I tell them, learn to write well. And all the teachers really applaud when I say that.
Yeah, no, it's absolutely critical. And the other interesting part of that is it's become even more important to express yourself well in English because with the AI era, a lot of programming, more or less, depending on your attitude about AI-generated code, but more or less people are needing to ask an agent to build something for them. And that's a real exercise in requirement specification. Like how well can you state what it is you want to build? And that kind of dovetails into another thing I like to tell them. I like to talk about planning. Like I'll ask students, how many of you have a plan for what you're going to be doing for the next couple of years in school or even what you're going to do afterwards? And all the hands go up. And then I say, how many of you have written it down? And I think they think like, why do I need to write it down? It's right up here. But the thing that they sometimes miss is the writing is how you clarify your thinking.
Yeah.
And it's not about capturing it. It's about developing it. So the process of writing is organizing your thinking, I believe. So I always encourage.
Yeah, there's somebody said, I'm not sure who it was, that's writing is thinking. Yeah.
Yeah. It's a way of developing or organizing what might otherwise be a bit of chaotic thoughts. So yeah, I always try to instill this idea of writing down a plan for what it is you want to accomplish, whether it's an app you're trying to build or what job you want to get next or whatever you're doing in life.
Have you had any experience with this AI stuff? Have you used it? Or?
Yeah, I've used it a lot. So in keeping with the education theme, I've been not really retired, I guess. I'm semi-retired because I've been teaching at a wonderful adult education institution here in London called City Literary Institute. And I'm teaching 3 courses. I teach Intro to Python Programming, and I use Google Colab notebooks for that. That's fun.
Right.
I teach Intro to AI, where it's partly how AI works, what neural networks are and how we train them and that kind of stuff. And partly like just showing them how to take advantage and use this technology with very hands-on kind of experience.
Oh, very cool.
And then the third one kind of ties everything together. It's called Build an App with Python and AI.
Uh-huh.
And that's brand new. I'm in the middle of teaching it right now, but it's really interesting and really fun. I'm using Google just came out with an agent built into their AI Studio product.
Right.
And it's pretty impressive. So you can build it only does front ends, web front ends. So you can build a pretty nice front end app with that. And then for a back end, I have them use Replit. And we just walk through building an app using AI. And I try to use that as a vehicle to teach them, not to trust all the code, to look at what's generated as best you can, to get the agent to document it for you, to get the agent to write tests for you. What is GitHub? Check your code into GitHub. How do you deploy it? You've got this AI Studio thing. It's storing things in Google Drive. Now you want to make it available to someone else. How do you deploy that app? So that's been a really, really fun course.
Oh, I want to take it.
I'm learning a lot. It's just the same thing I was mentioning.
Oh,
about,
absolutely.
like how I tell kids to teach. I'm learning a lot about using AI to build apps through this course.
Yeah, that's actually something I've been sort of marginally involved in with students. So now that I'm retiring, I'll probably be doing more of it. So one of the things I've been doing is doing mock interviews, trying to give students the experience what it's like to interview for a job. And,
that's great.
They need a lot of practice.
That's a great idea. Yeah, I have a video I made where I shared maybe in a half hour tech tips for doing tech interviews. We've been down some very similar paths. It seems.
Yeah. All right, this is great. So thank you so much, Marc.
Thank you for having me.
It was such a pleasure to talk to you.
It was great talking with you as well.
To our listeners, we hope we'll see you in the next episode. Thank you.